Hello everyone, welcome to GDC classes. So today is the fifth day of the 100-day biopharmaceutics challenge in which we are going to cover the factors affecting drug absorption. In the previous videos, we have already covered the introduction of the absorption, what are the basic mechanisms, what are the main transporters that are involved. So today let's cover about the basic factors which are going to affect the drug absorption. Now the factors are classified basically into the pharmaceutical factors, which will include your based on the drug substances, because the drug pH, drug solubility, how the drug is going to be ionized, what fraction will remain unionized, that is going to impact a lot about your drug absorption. Second will be your dosage form, which indicates whatever dosage form that you have used, what will be its disintegration time, what will be its resolution time, what will be the manufacturing variables, what are the excipients which you have used, what is the nature of the dosage type of the dosage form which is used, right? So based on that, your bioavailability also significantly varies. Next will be your patient related factors, which includes age, gastric emptying time, intestinal transit time, gastric pH, disease state, blood flow, GIT contents, contact time, and pre-systemic metabolism. So the basic parameters are going to be from the drug, then what is the dosage form, then to whom it is being administered, what is the actual condition of the patient. So few important factors that we need to see, I will just cover those for you all. So number one is going to be, let's suppose for the drug factors, right, related to the drug factors, number one is going to be your particle size. Now once you have understood this concept, that reduction in the particle size, you have seen reduction in the particle size is going to increase the effective surface area, which is going to improve the dissolution, which is going to increase the bioavailability. So based on the size of the particle as well, nature of the particle and size of the particle, the bioavailability will be significantly impacted. The absorption is also going to be impacted first, then we say the bioavailability. Second will be your polymorphism or apomorphism. Second will be your polymorphism or amorphism. So we already know what is polymorphism, right? We already know what is the crystal structures, which we already know what is the amorphism. So in the crystal structures, you already know based on the stability, the crystalline substances are more stable than the amorphous ones, right? The crystal structure is more stable than the amorphous ones, right? So based on the stability, based on their lattice, the stability of crystalline structure is even more. Okay, based on the hydrates and solvates. Now you know that hydrates and solvates, in the case of hydrates, you can see that it can form stronger interactions. In the case of hydrates, you can see it can form hydrogen bonds, which will be a stronger interaction that can make it even less soluble than the anhydrous form actually, right? So based on the solubility, your anhydrous form will be more soluble than the hydrates, because of the stronger interactions it is going to form, that is going to be make it even less soluble, because it ultimately will dissolve slowly because of the stronger interactions. Next, it will be based on the drug pH, pKa and GIT pH. Okay, you all know the acidic drugs are going to be absorbed from the acidic environment only, right? So acidic drug absorbs from the stomach. We all know this thing, that acidic drugs absorbed from the stomach, and basic drugs need basic environment. So basic drugs are going to be absorbed from the intestine only. That means acidic drug in acidic pH, acidic drug in acidic pH will remain unionized and will be absorbed. Acidic drug in basic pH, it is going to be ionized and not absorbed. Basic drug in basic pH is going to be unionized and well absorbed. Basic drug in basic pH, acidic pH, it is going to get ionized and not absorbed. So ultimately we have to see that the unionized fraction will be more absorbed. So acidic drug will be better absorbed in the stomach that has the acidic pH, and basic drug will be better absorbed in the intestine which has the basic pH. Next, we all know that the lipophilic drugs are actually able to cross the membrane quite easily, right? We all know the lipophilic drugs based on the concept of like dissolved like are able to pass through the membrane very easily. So that means the log P values which will indicate the permeability will be in line with the lipophilicity, right? So the drugs which are based on the nature of drug, it is going to be lipophilic. It is going to easily cross the membrane. So the drug with a sufficient log P which will indicate its lipophilicity. So what are the basic drug characteristics which will be make it more orally effective? Based on the Lipinski rule of 5, we have to say the size must be less than 500 Dalton. The log P must be around 5. Hydrogen bond acceptor should be less than equal to 5. Hydrogen bond acceptor should be less than equal to 10. So you can see the molecular weight is an important characteristic for a drug to be orally effective. Your log P value should be less than equal to 5. That is going to indicate the lipophilicity. Your drug hydrogen bond acceptor less than equal to 5 and hydrogen bond donor less than equal to 10. So all these characteristics are based on the Lipinski rule of 5. Based on the Lipinski rule of 5, which is going to indicate that the drug will be orally effective or not. Other than that, if you want to talk about the transit time, that is how much time the drug is going to take to pass through the different regions of the GIT. For example, in the duodenum it is going to be the 5 minutes, in the jejunum it is going to be 2 hours, in the ileum it is going to be around 3 to 6 hours. So how fast it is going to cover these areas, that is going to depend on that also. Next we have is the presence of food. Now in some cases of some drugs, the absorption might be enhanced, delayed, decreased or even have no effect. But before that, I think this point is clear to you. If the log P will be more, that means the permeability will be more. That means the membrane will be crossed. That means absorption will be better. That means bioavailability is going to be better. So log P more. So you have a good permeability characteristics. So the permeability is going to be more. It is easily will be crossing the membrane. The absorption will be more, and so as the bioavailability, right? You must be able to connect these dots now. So next we have the presence of food. Gastric emptying time is one, right? And then we have presence of food. Just like I have mentioned, the presence of food can have multiple effects. It can actually increase, it can decrease, it can delay, or it may have no effect on the drug absorption. Based on these, we have important example listed. For example, if you want to see the enhanced one, using the high fatty meals, we can actually increase the absorption of the griseofulvin, which is the antifungal drug. So using the high fatty meals can impact their drug absorption. It can increase it. For the delay, if you want to see aspirin is actually the absorption of aspirin is actually reduced in the presence of the food, right? For the decreased one, you can see, you can take the example of penicillin. So the drug absorption, the penicillin absorption is actually reduced because of the presence of the food, right? For the no effect, we have an important example of methyl dopa, which is not affected by the presence of food. So these are the important example for the drug whose absorption is going to be impacted through the presence of food. Okay, we'll meet in the next class. Till the time, revise the previous video and we will surely meet for the carrier mediated capacity limited process, which includes the Michaelis-Menten equation in the next short video. Thank you so much.